Graphs of radical functions. We're going to graph f of x equals the square root of x, and we're going to do it using a table of values. So we're going to pick values of x to determine what the value of y is, and then we're going to graph those points on the graph. So I'm going to lead us through this, and I'm going to pick a value of x to show you an important point about radical functions. So I'm going to pick x equals -1, which is over here on the graph, x equals -1. And when I pick x equals -1, I stick it into the function f of -1, so that would be the square root of -1, to get the y value. And what I find is that the square root of -1 does not exist. And as we talked about previously, it's because x is not in the domain of this function, because you cannot take the square root of -1. So there is no point on the graph with an x value of -1. Let's go ahead and move up an x value to x equals 0. And now to find the y value, we would take the square root of this x value. Again, we're sticking it right in there for x. X equals 0, y is the square root of 0. And what we get is that if x equals 0, the square root of 0 is 0, so x equals 0 and y equals 0. So the point on our graph would be 0, 0. So this is the smallest x value that's allowed or will be on the graph, the most negative x value that will be on the graph, because you can't take the square root of a negative number. And again, we're going to move up by 1. So x equals +1, y is equal to the square root of +1, which is 1. So if x equals 1, y equals 1. So x equals 1, y equals 1. And we can find that here as x equals 1, y equals 1. So there's the next point on our graph. Let's again try moving up the x value by 1 and see what happens when we pick x equals +2. Well, now we have the square root of 2. And the square root of 2 cannot be simplified. It's not a perfect root. So the point on the graph for x equals 2 has a y value of the square root of 2. But that's not on a grid line. Our grid lines they land on integers. So this isn't a good point to choose to graph. So instead, what I'm going to do is I'm not going to just pick any x value. I'm going to pick x values that are easy, or I should say, that have nice y values. So x equals 4 would be a good example, because when I take the square root of 4, I get y equals 2. So the point x equals 4, y equals 2 is on the graph. So x equals 4, y equals 2. So that's a good one to pick. Another one, a good one to pick would be x equals 9. Because the square root of 9 is equal to 3. So the point x equals 9, y equals 3, also on the graph. So now we have a bunch of points, and we can go ahead and sketch the line, which you can see curves to get through all those points. And that's the standard shape of a radical function. You can see that to go up one x value at the beginning, it happens pretty quickly, but then to go up another x value takes longer in terms of x. And so basically what we call this is a slowly increasing graph, because it takes more and more x values just to climb up one y value. So now looking at, I'm going to use one that I haven't sketched, a graph of f of x equals the square root of x. So you can see those same points we found. 1, 0, 0, 1, 1. When x is equal to 4, the square root of 4 is 2. When x is equal to 9, the square root of 9 is 3. And when x is equal to the square root of 6, or when x equals 16, y is 4. So there's that slowly increasing curve. And what I want to note is the domain and the range. So the domain is all the possible x values. And as we saw previously, for a radical function, what's underneath the radical needs to be positive. So in this case, x needs to be greater than or equal to 0. So we can see that from the graph here. This whole line has x values that are greater than or equal to 0. X can be positive 16. If we kept going, it could be equal to positive 100 or positive 100,000. It can be anything as long as it's at least 0. In the range, we can also see what are the possible y values that this function can take. And we can see that it starts climbing. Its first y value is 0, and it has all the y values above that. And it keeps continuing upwards and upwards. So again, as long as x gets big enough, the square root of that will be some positive value. So the range is y is also greater than or equal to 0. For the second example, we're going to follow the same strategy, which is we're going to graph this function using a table of values, and then we're going to state the domain and range. So let's just start by setting up a table of values, x, y. And again, we're going to pick values based on what's underneath the square root sign, something that we can take the square root of nicely. For example, if we picked x equals -1, this would be a poor value to choose because we would then have that y is negative the square root of -1. And we cannot take the square root of -1, so it does not exist. So instead, we'll pick an x value like x equals 0, and then we have negative the square root of 0. And this equals 0. Right, we could, if we want to simplify it slower, we could say -0, which is just 0. 0 doesn't have a sign. So 0, 0 is on the graph like it was previously. But now let's watch what happens when we pick x equals 1. We have negative square root of 1. And negative the square root of 1 is just -1. So that would be an x value of 1 and a y value of -1. So x value of +1 here, but a y value going down of -1. And if we pick an x value of 4, again, something that we can take the square root of, we have negative the square root of 4 is equal to -2. So from x equals +4, we have y equals -2. And lastly, I'll pick x is equal to 9, y is equal to negative the square root of 9, which is equal to -3. So these points were 4, -2, and now 9, -3. So over 9, down 3, and just by connecting these dots, we see we have this slow curve. I'm going to sketch this again here. This slowly curving line. And then finally, we're going to note the domain and the range. So the domain, we can see that x values for this function are just bigger than or equal to 0. But for y values, we see that now they're dropping below. This line, this function, only has y values that are less than or equal to 0. So it's all the negative values. So there's our domain and range. If we take the graph f of x is equal to the square root of negative x, we're going to find that we have to think about what values of x we can take the square root of a little bit more. So for example, it's always a good idea to try 0. If x equals 0, we have the square root of negative 0, or it doesn't matter what the sign says, 0 is just 0, so the square root is 0. That would be a 0.00. Again, this is on our graph. It's not going to be on every graph. We'll see an example of that soon, but we've seen it come up a couple of times now. If we were to pick x equals 1, we would have the square root of negative 1. So this would be a bad value to pick. So we're not going to choose that one. Instead, we'll have to think, well, that negative in front of the x here in the function is reversing the value of x. So instead, I'm going to pick an x value like negative 1. Then I have the square root of negative 1, which is the square root of positive 1. So the x value is, for the x value of negative 1, y is equal to 1. So now I'm going over to an x value of negative 1 and up to a positive y value of 1. And now I'm going to follow that similar pattern. What's the next convenient value of x I could choose? Well, let's try negative 4, because I know that the square root of 4, so that's the square root of negative 4 is the square root of positive 4, is 2. So that would be negative 4, comma 2 is on the graph. Negative 4, up 2. And similarly, if we pick negative 9, we'll have the square root of negative 9, or the square root of positive 9, which is 3. So negative 9, comma 3. So you can see that these negatives often reverse the direction of the graph. So now I'm going to go ahead and try to very smoothly connect these lines. That last line I did was no good. Very smoothly connect those lines, and there's the sketch of our graph. And we will note the domain and the range. This time, all of the x values for this line are going to the left, which means that x is less than or equal to 0. And for the y values, they're all climbing upwards from 0, so all the y values are greater than or equal to 0. And we can see that in our points. We can see that the x values are going down from 0 to negative 1 to negative 4. They're getting smaller and smaller and more negative. And the y values are going up from 0 to 1 to 2 to 3. They're climbing upwards. And the last example we're going to do has x plus 4 under the radical. So we're going to pick x and y values, but we have to be careful to pick values that are convenient for graphing. So in this case, I'm trying to sort of think ahead. What's the value of x that would make this radical 0? Well, if I pick x equals negative 4, then I add 4 to it, I get the square root of 0. So that's like the beginning of this graph. So I'm going to start by picking x equals negative 4. And then I get the square root of negative 4 plus 4, which is the square root of 0, which is 0. So I have the point x equals negative 4, y equals 0 on the graph. So x equals negative 4, y is equal to 0. There's the first point on my graph. And again, now I'm going to start thinking about what x values are, and I'm going to start thinking about climbing my x value up so that I can take the square root of the next thing. So what value of x would mean I could take the square root of 1? Well, if I picked the x value negative 3 and added 4 to it, I would get the square root of 1. So that's what I'm doing in these graphing problems. I'm trying to find convenient x values so that I get nice y values. That's the key. So if x equals negative 3, y is equal to 1. -3, comma 1. And again, doing this again, if I pick x equals 0, this is a nice one because I have 0 plus 4, which is the square root of 4, which is 2. So don't be afraid if you need to use a little bit of trial and error to find these nice points. Take some practice to get used to it. But after a little practice, you can get the graphs very quickly doing this. And then again, I'm thinking about now the square root of 9 would be the next point I want for the y value. So again, I'm thinking towards how do I get the square root of 9, which is y equals 3. Well, then the x value I'd have to pick would be 5, because 5 plus 4 equals 9. So the x value I'm going to pick is 5. So that would mean that if x equals 5, y is equal to 3. So x equals 5, y equals 3, and now connect these points. Take your time, make sure it looks like a nice smooth curve. And there's my graph. And then finally, state the domain and state the range. So the domain, we see all the x values are climbing from x equals -4 onwards. So the domain is that x has to be greater than or equal to -4. That was the smallest x value that gave us that we could, that worked in this square root function. It was the smallest x value. Smaller x values would have resulted in negative square roots or square roots of negative numbers. And the range, we see the y values climbing upwards. They start as low as 0 and then climb upwards. So the range is y is greater than or equal to 0.